On June 11, 2020, it was reported that scientists aboard the International Space Station had managed to create a specific substance in space for the very first time. This was hailed as an experiment that could potentially help us unravel some of the deepest mysteries in physics in the near future. The substance that they created is called a Bose-Einstein condensate. But what exactly is this? How do you even make one, and why are they so important? A Bose-Einstein condensate, or BEC for short, is quite commonly referred to as the fifth state of matter. It is a state in which a group of atoms, or specifically subatomic particles known as bosons, when cooled to extremely low temperatures, occupy the lowest possible energy level and thus combine and behave as if they were a single unit. This theory was first predicted in 1924 by an Indian physicist, Satyendranath Bose, based on his work on photons, and the theory was later developed and extended to atoms based on his collaborations with Albert Einstein in 1925. However, the first BECs were only experimentally made and verified only in 1995, nearly 70 years after their prediction. So how exactly do you make one of these things? Let's find out. The general idea when making a BEC is to inject atoms, usually rubidium or potassium, into an ultra-cold chamber to slow them down. A magnetic trap is then created in the chamber with an electrified coil, which is used along with lasers to move the atoms into a dense cloud where they eventually start to blend together. The BEC usually begins to form when the substance is extremely close to absolute zero, which is 0 Kelvin or minus 273 degrees Celsius, about 277 degrees cooler than your average refrigerator. At this temperature, atoms begin to coalesce into a single quantum mechanical entity that can be described using a unique value known as a wave function. Also, if you are wondering what a BEC actually looks like, this is an image we have of two BECs in interference. So now that we know how to make a BEC, the biggest question that remains is, why are they so important? What are they even used for? While we're still unaware of so many of the properties and possibilities that BECs have to offer, the prospects that we are aware of are staggering. BECs have been linked to two very interesting properties that we hope to explore. The first, superfluidity, the property by which a fluid can flow facing virtually no friction. And the second, superconductivity, the property by which electricity can be generated by electrons that are flowing facing virtually no resistance. And these two properties can help improve so many fields, including the development of an atomic laser, improvements to atomic clocks, and improvements to quantum computing. And this is just from what we know. There's still so much research we're yet to do to discover the limits of what BECs have to offer to us, including their connection to dark matter and dark energy, and their ability to slow down light itself. And this serves as a testament to the fact that BECs are wonderful, mysterious things that are surely going to help us expand the keyhole through which we've been looking at the universe very soon.